Okay, in this video, we're going to be doing Calc AB Problem Set 88. The problems and a playlist are in the description below, and let's do it. Number one, the slope of y equals f of x for all x is given by 6x minus 13. That's like a weird way of writing a problem, but the College Board likes to write a lot of problems like that, and a lot of review books have them. I don't know. I think it's weird, but so that's the slope for any value of x is 6x minus 13. That's the derivative. That's f prime, right? I mean, we know that. If f of x passes through negative 2, 1, find f of x. All right, so we got to go from f prime back to f. That's an antiderivative. I'm just going to write down f of x equals, reverse the power rule, right? So plus 1 times the reciprocal gives us 3x squared minus 13x. Do not forget plus c. This whole problem is based on plus c, really, right? Because now we know that we also go through negative 2, 1. So I'm going to plug in negative 2 for x, and I'm going to set this thing equal to 1 and try to solve for c. So 1 is 3 times negative 2 squared, and then minus 13 times negative 2 plus c. So that's going to be 1 equals 12 plus 26 plus c. That's 38 on the right side, but when you move it over, you're going to do 1 minus 38, negative 37. So c is negative 37. And then we just write down our function. So it's a pretty straightforward problem if you recognize the fact that it's just giving you the derivative in a bizarre way. It's not like the weirdest way in the world, but I think it's a little weird. All right, next up, find a and b so that the given function is differentiable. So I'm just going to find a and b in this case. I'm not going to then prove that the function is differentiable. So I know for a function to be differentiable, the function must be continuous. And you always have to remember that because you always get two equations when you're doing this. Two equations and two unknowns. Usually, one of them comes from continuity and the other comes from setting the derivatives equal to each other. So let's do it. So for a function to be continuous, we need the limit from the left equal the limit from the right to equal the value of the function. So we need the limit as x approaches 0 from the left to equal the limit as x approaches 0 from the right to equal f of 0. Now, if we take the limit from the left, that's using 3x minus 2. So I don't know if I even read the function. It's 3x minus 2 when you're less than or equal to 0 and sine of ax plus b when you're greater than 0. So the limit from the left uses the branch 3x minus 2. If you plug 0 into that, you just get negative 2. The limit from the right uses the branch to the right of 0, so when x is greater than 0. So sine of 0 is 0, so we actually just get b equals negative 2. That's pretty good because it's less work. You could have gotten an equation that was like 3a plus b equals 5 or something, and then you'd have to do a system of equations at the end. Here we already know b is negative 2, so this is going to go smoothly, hopefully. All right, to make this thing differentiable now, we got to take the derivative. So we're doing the derivative of each branch. And when you do this, you just leave off the or equal to from the inequalities of the branches. So the derivative of 3x minus 2 is 3. Now, in the function, it's when x is less than or equal to 0. Here, it's just going to be when x is less than 0. Because we don't know. We don't know if we can even make this thing differentiable. We don't know the derivative at 0 yet. And then we'll do the derivative of sine ax plus b. The derivative of sine ax is a from the chain rule, cosine of ax. And then the derivative of b is 0. So we get a cosine of ax. And this is when x is greater than 0. Now, for this to be differentiable, it means we have to be able to plug 0 into both of them and get the same thing. So plugging 0 into 3 just gives you 3. That doesn't do anything. And then when you plug 0 into a cosine of ax, you get a cosine of 0. Cosine of 0 is 1. So you actually just get 3 is equal to a. And this is great. There's no system at the end of it. It's just like we already knew what b was. Now we know what a is. So I'm going to say f of x is differentiable for a equals 3 and b equals negative 2. If we have that combination of a and b, we'll have differentiable. All right, let's look at another problem. Given that f prime of x equals the quantity 2x plus 1 cubed times the quantity 3x minus 4 squared, we want to find the x coordinates of the points of inflection of f of x. All right, so it's important to note we are given f prime. We were not given f of x, which, like, thank God, because I wouldn't want to find the second derivative of this thing. We just need to find the derivative of this thing. So we need to find f double prime because that's the derivative of f prime. So it's going to be product rule with some chain rule thrown in. It's first. Derivative of the second, you're going to get a 2 from the power rule and a 3 from the chain rule. So 6 quantity 3x minus 4, and then plus second, which is 3x minus 4 squared. Derivative of the first, you get a 3 from the power rule, a 2 from the chain rule, so 6, 2x plus 1 squared. Now you can definitely take out a 6, because that showed up twice, a 2x plus 1 squared, and a 3x minus 4. You can take out all of those things. So I'm going to do that. I'm not going to make you watch that. So I took out 6, 2x plus 1 squared, 3x minus 4. Now what's left over? You are left with a 2x plus 1 from that first product, and you are left with a 3x minus 4 from the second. So this is also kind of the ideal scenario. It's kind of annoying when you can take out like the constant 6, but there's like a 5 and a 2 left over or whatever, and then you have to distribute and keep track of that. Not in this case. All right, so we do have to combine those. So that's 2x plus 3x is 5x, and 1 minus 4 is negative 3. So we have a 5x minus 3. So let me write that over again. And now we're just going to do a sign chart, right? So the zeros of this thing are negative 1/2, 4/3, and 3/5. So in order, that's negative 1/2, 3/5, and 4/3. Order matters. I'll be honest with you. When I first did this problem, I put... so I accidentally solved 5x minus 3 incorrectly, and I got 5/3. And then I had like negative 1/2, 4/3, 5/3. And I'm like looking at it, I'm like, something feels weird about this. And then I checked it on a calculator and I had done it wrong. So that's fun. So we got negative 1/2, we got 3/5, and then we have 4/3. They have to be in order, or your conclusion will mean nothing. If you plug in negative 1 billion, you're going to get 6 is always positive, something squared is always positive, then you get negative, negative. 2 negatives make positive. Negative 1/2 comes from 2x plus 1 squared. Squared is even, so there will not be a sign change. So you still have pluses. 3/5 comes from 5x minus 3 to the first. 1 is odd, so you will have a sign change. 4/3 comes from 3x minus 4 to the first. 1 is odd, so you will have a sign change. Or you could just plug in 1 billion. So the only sign changes are at 3/5 and 4/3. So that's going to be our answer. And I'm just going to like flash it up on the screen. F of x has points of inflection at x equals 3/5 and x equals 4/3 because f double prime changes sign there. That's all you need to say. For points of inflection, you do not need to say f double prime changes positive to negative, negative to positive. You just need a sign change of any variety. So we'll just say it changes sign. Nothing happens at negative 1/2, so I'm just totally ignoring it. You might, if you're worried about that, you could also add in a sentence like f double prime of negative 1/2 is 0, but there's no sign change. Therefore, no point of inflection. Up to you. I think this is good enough. That's the problem set. I hope this was helpful, and good luck.